before we do that, we need to define equalities or equations. Okay, so linear equations are first degree. For example, x plus 2 equals 5. So that's an equation because it has an equal sign. And there are usually two statements on each side, or two expressions. For example, this is an algebraic expression, as we saw before, numbers and letters. The other side could also have numbers and letters on this side. And the equation has an unknown, which we try to solve for or find. In this case, it's x. So basically, there is a number when added to 2, that number is 5. So we're gonna, when we find that number, for example, obviously the number here is 3. So we say the solution is 3. Why? Simply because if you take this solution and you plug it, you can find that it works. For example, if you plug 3 here, it'll be 3 plus 2. And we say, is it equal to 5? When you check, we use a lot of question mark here until we simplify. So 3 plus 2 is in fact 5. 5 here, so that works. So this solution actually, we say, checks. So that's a valid solution. So it's pretty much the whole concept, the whole idea of equations. Find the missing number. Once you find it, check if it works. If it works, then you're done. If not, you backtrack and you try to find where things went wrong. So you cannot go backtrack it from here. You can go back here and all the way to the original problem. So this is what we call, again, first degree or linear equation. The reason why we call them so is because the variable here has power 1, not 2 or 3. Those would be different types of equations, quadratic or cubic. But today we're only going to be talking about first degree. That's when the power of the x is 1 or an invisible 1. We call this first degree or linear, same day linear equations. Okay, and in general, there's always an x, like I said, and there's an equal sign. That x is to the first power. It might be one x or maybe multiple x's here and here, but it's always in this form. So we have some number here, maybe some number here, and some number on the other side. So something like this, ax plus some number and some number on the other side, just like here. Here we have a number. The visible coefficient here is 1. So 1x plus 2a plus 2 equals 5. This is what we call the standard form. Okay, the standard form follows first degree equations, and again, power must be 1. If it's different than 1, then it's not a first degree or linear, it's a different type of equation. All right, so that's basically what equations, what first equations, first degree equations are. And it's not always this simple. This is just a simple example I choose, but as we're gonna see, it's gonna get more complex, like it's gonna get longer with more terms on both sides, parentheses and everything. But we're gonna take that one step at a time and see how to solve. Okay, so it takes us to the next section, which is solving. Solving linear equations. All right, so back to this problem here. So we said the solution is 3. Let's see how to actually get that solution here. So basically, you want to get the value of x. You want to isolate the x. So we need to cancel this number here. To cancel positive 2, how do you cancel positive 2 from this? So we could have x by itself. Positive 2, how do you cancel it? If you want to eliminate it from here, so what do you do on this side and on this side? If you guys know, before I give you the...
Call it the inverse. So you subtract 2 and that'll cancel out on the left side, and then you subtract 2 by 5 and it'll give you x equals 3.
Exactly. So exactly. So to cancel this, we need its inverse. That's what we called last time, the additive inverse property. So to cancel something, we just need its opposite. So these two cancel out. We have x left, but it's an equation. You do the same thing on both sides. You can't just do one thing here to change. Whatever you do here, you have to do on the other side. So we have to subtract from here as well. So that cancels out. We end up with 3. That's why we said 3 earlier here. Okay, this is also called the subtraction property of equations. Subtraction property is when you subtract from both sides, or the addition property if you add to both sides, and so on. Okay, so that's probably the simplest equation you'll ever see. Let's look at another example. So this basically took one step equation. It's not always the case. It may take 3 or 4 or 10, depending on how long the expressions are in the equations. So let's make things a little longer here. And maybe 12. So this one here, again, the purpose of solving is to get the x by itself. So we want to get that x by itself here equals some solution. So what numbers need to be eliminated from this side in order to get the x by itself? What numbers? So we have two numbers here. We have this number and that one. So we're going to cancel both of them. Once we do that, we're going to have the x by itself. So in this case, we have -4. What do we need to cancel this -4? Anybody? What do we need?
+4.
That's right. So we need the opposite of -4, which is positive. And also do the same thing on the other side. If you add 4 here, you gotta add 4 because this is like a balance or a scale. You want to keep it balanced and equal. Cancel that. That's 16. We're not there yet. Now we need to cancel the 2. How do you cancel that 2?
Divide
That's
2
right.
to both sides, and it'll give you 8.
Exactly. So here we have a 2x, which means 2 times x. The opposite of multiplication is division. So we're going to divide by 2. So this cancels out. You end up with x by itself. And of course, divide the other side. 16 take away 2 gives you 8. So that's the solution to this equation. X is 8. You can easily check if you plug this here, simplify, and see if it works. So this one here took 2 steps. So the more stuff you put in an equation, the more steps it will take to solve. Okay, solving linear equations. So here we did what we call the addition property of equations because we added to both sides. Then we divided, so we call that the division property of equations, to the subtraction, and so on. That's what we call the properties of first degree equations. Okay, let's throw in some parentheses now. Say x minus 1 plus 6, maybe negative, say 3 or 9. Okay, equation getting a little longer. Of course, obviously it's going to take more steps than the first 2. But again, we look at the equations, we look at each side as an expression, as we saw last time, algebraic expressions, combination and combination of numbers and letters. Whatever we did with expressions last time, we can do with each side of the equation, basically. Again, the purpose is to get the x by itself and find the solution. So let's work on this side now, the left side here. What do you think we need to do first? On this side here, so we're going to try to simplify this expression here. What is the first step to do here? think of it.
First
Think
step
of
is here is distributing 3. So you'll start it off with distributing it to x and -1.
okay,
And you'll get 3x minus 3 plus 6 equals -9. And then you'll work from there.
exactly. So just like we saw last time with the algebraic expressions, simplify this, we need to distribute. So to clear the parentheses, so 3x minus 3, bring the 6 down, equals, and on this side, if you have parentheses or like terms, you do the same thing. But in this case, we only have 9. So before we can subtract and add to both sides, we need to work on each side first, separately, and simplify it. Once you simplify it, it may turn into something like this or that like this, which will be easier to deal with. Okay, now that we distributed, we can combine the like terms here. These two go together. So 3x plus 3, okay, and we have -9. So you can see, now it looks like that. I'm going to repeat these steps again. I'm going to cancel the 3, this one, and then cancel the other 3, and we'll have the xy stuff. Again, the opposite of positive 3 is -3. Do that on both sides. That cancels, so 3x, this one here, -9 minus 3 is -12. And finally, just like here, divide by 2. Here we divide by 3, also divide by 3. These cancel, and you get your solution here. -3 or -12 by 3, that is, that's the sign negative division, that's 4. And that's our presumed or our proposed solution. As always, you can always check to find out. Okay, so we can always do that little check on the side. So let's check here, see if this actually works. Okay, all we have to do is take the 4, the -4. We're gonna plug it into the equation here and simplify to find out. So 3, the solution here, x -4 minus 1 plus 6. We don't know yet. We don't know for a fact whether these two are equal, so we're going to put that question mark. So that's what we're trying to find out. All right, so according to the order of operations, where do we start from here to simplify? We want to simplify this side here, see if it's equal to -9. What are you going to do? The parentheses first, so we're going to evaluate this first. What's -4 take away 1? Everybody, what is -4 minus 1? The signs we talked about last time.
Three.
Not 3. It's a -4.
5.
Minus 1. What kind of 5?
Positive.
No, it would be a -5. So we keep the sign and we add the two values. Okay, we talked about this in detail when we discussed the signs in the previous class. Bring down the +6. Equal sign again, -9. Now we have multiplication and addition. Which one do we evaluate first? According to the order of operations, which operation is done first here?
Multiplication.
That's right. Going to evaluate the multiplication. 3 times -5, that's -15, plus 9. Again, we're not sure yet. We need that question mark. And see now one final step. What is -15 plus 6? So again, that's where signs are useful. So we need to know our rules very well in order to figure this out. -15 plus 6 is, pick the sign of the higher number. There are different signs, so we're going to do the difference. What is the difference of 15 and 6?
9.
9. That's right. And now we have negative 9 on this side. So now we know for a fact this is a true statement. No need for that question mark anymore. And therefore the solution is valid. So we say it checks because we just checked it and it worked. And that's pretty much how we solve this type of equations. Basically, look at it as each side as expression, a simplified expression, then isolate x using one of the properties, either addition or subtraction or multiplication or division. It's also a good idea to check your solution afterwards. Let's say you get something here that doesn't make sense. Let's say 5 here or something and negative 9. And that's unacceptable. It means the solution is wrong. So you gotta go backtrack. Not start from here, but backtrack your steps from here, one after the other, and see where you made the mistake. It could very well have been a mistake here. This might still be the right solution. Maybe you made a mistake when you plugged it. Doesn't mean this is wrong. You just did the wrong math here. You missed a sign or two. So check here first. And if you don't find a mistake here, then you go back and check your steps here. So this is a multiple step. Multiple step equation. As you can see, it took us a few, at least do this part. This, usually you can do on the side. If you want to show it in the work, in the homework, that's fine. If you want to show this, that's fine. But this, you have to show all these steps here. Any questions so far, everybody?
No, sir, no questions.
Let's make the equation a little longer now, maybe some more things. All right, so there's another one. It's a long equation. Pay attention here, it's not actually that difficult to solve this. Pretty much going to repeat the same steps here. It's going to be some additional steps here because it's longer, but no big deal. So again, you look at the equation and you look at each side as an expression. So we have an algebraic expression here, another algebraic expression. And work on each one on its own first, before you start doing minus 5x and minus 5x. Work on this one first, make it maybe something as simple as this first. The other side will also probably be something like this. And basically simplify, let me say simplify each side first. So that's your first step. And by that we mean clear the parentheses or the distributive property. Clear the parentheses, combine like terms. That's the first step. So let's do that and see what to do next. On this side again, just like we did over here, parentheses first. I mean the distributive property first. Do not subtract this first, okay? This is the last thing you want to do is subtract. Always clear the parentheses first using the distributive property. And this negative here belongs to the 2. So when you times, make sure you consider that negative here. Bring the 7 down, and we're going to distribute these. So negative 2 times 3x, negative 6x, negative 2 again times positive 1, which is negative 2. Okay, not just 2 times 3 with a sign here. Take that sign and multiply. Bring the 5x down, and so on. And then we're going to start the same thing on the other side. Okay, I'm going to have a distribution here. We have a parentheses. What is this equal to? If you have a negative, you have a negative here. What's negative times negative 4x?
Positive.
That's right, negative times positive. You can think of this as a -1, if that helps. -1 times -4 is positive 4x. And again, -1 times positive 2, which is -2. Bring the 8 down. Back to this side. So after clearing the parentheses, we need to combine the like terms. Okay, what like terms do we combine here? 7 with you have a number here. We're going to combine the 7 with which term from here? The like term to 7 is this, -2. Also combine this -6 with +5. So 7 and -2. 7 minus 2 is 5. And you have -6x plus 5x. What is that equal to? -6 plus 5. What is it? So again, the signs are very important here. You don't want to miss or get any sign wrong. Otherwise, the solution will definitely be wrong. -6 plus 5. That would be?
-1.
That's right. This is a -1. That's very important because that -1 will be here. So we're going to do -1x. And move on to the other side. Pretty much do the same thing. So here now, 4x, there is no x here, it stays the same, positive 4x. These two together, -2 minus 8. Let's again combine, add the numbers, keep the same sign. So that's okay, 5 minus 1x. All right, so you see now the equation looks a lot better. See here was so long and a lot of stuff. Once we simplify it, it becomes much easier. Pretty much like the previous ones, almost like the previous ones. There's a lot of difference here. How is this equation different from the previous ones that you've seen so far? What exactly is different about this equation compared to the previous ones? You guys noticed anything different here in this equation? If you look over here, we have the x here and the x also on this side. And we'll have some numbers on both sides. So what we need to do is we need to have both variables with x's here and both numbers on the other side. So you can do -4x here. If you want to cancel this, do -4x here. Cancel it, and then cancel the 5 from here, -5, or is a better, probably a better way and a faster way. We can do that at the same time. So you can move this over, or rather move it next to this one. And the 5, we can move it back here next to the -10. That way we would have the x's here and the numbers here. But something important happens when you do that. So first of all, this stays here. So -1x will be here. If we take this positive 4x, you move it across the equal sign to the other side. What happens to it? Something happens to this if it moves to the other side. What exactly happens to this 4x? Anybody want to try?
3x.
Before that, before we combine it, just the term itself, positive 4x, before we combine, we just want to move it first. We're going to put it over here, but something about it changes when we move it to the other side of the equal sign. What does exactly change?
You have to get it all basically on one side. Only exponents by itself.
I'm sorry, repeat that. Couldn't hear it.
You basically have to get all the variables by itself. So you have to either -5 or +10 on both sides.
Okay, you can do -5, -5. You can subtract the 4x and 4x, or to get them together, we can move this over to the other side. So whenever you move something to the other side, this is the faster way. You can do both at the same time. If we move something to the other side of the equal sign, just change the sign. It becomes -4x. Positive becomes -4x. And this 5, if you move it to the other side, it becomes this one here. So +5, it moves over, becomes
-5.
-5. So this is a faster way. You do both at the same time. Just move the x's to one side, to the other side, the numbers to the other side. All you have to do again is just change the sign of whatever thing you move to the other side. If you just move it within one side, you don't change the sign. Let's say you want to move 5x next to this one, no need to change the sign. The sign stays the same. But if you move something across the equal sign, that's when you change the sign of it. Okay, now that we have, so 1 simplified, we simplified number 2, as we did here. To move the x to one side, or the x's to one side. And the numbers don't forget to change the sign. That's important. This is faster than, you can still use -5 here, -5, and then use -4x, -4x. I believe this is faster and easier. You don't confuse the signs, or you don't have to guess what to subtract from where. So just move the x's to one side. Either side basically is fine. You can have them here or here, as long as you have the like terms or the like terms on separately on one side of the equation. All right, so now third step. So what do you do now? What is -1x minus 4x? We combine these. What do you get?
5x.
Not exactly 5x, but we combine -1 and -4. -1 and -4. What is that equal to? As we did earlier here. For example here, -2 minus 8 is -10. What's -4 minus 1? Anybody knows that?
Did it fly?
-5. That's right. Again, the signs are very important here. You have to be sure about them 100%. You can't guess them, or you can't have a lot of doubt. There's 2 rules only for addition and subtraction that we learned last time, and 2 for multiplication and division. Just 4 of them together. Go over that lecture again, understand it, and you'll never get the signs wrong again. It's very simple. Shouldn't confuse these, okay? That's very important when it comes to equations. That's -5. And over here, same rule. Keep the sign, add the 2. What is the final step? One more step to get the x by itself. What do we do now? Divide.
Division.
Okay, by?
-5.
Exactly. So you want to cancel this -5? You got to divide by -5. It's not add 5 or something. We divide because we have a multiplication here. It's 5 with negative 5 times x, so you divide by negative 5. And also here, you gotta divide by negative 5. So if that cancels, you get x by itself. What is this equal to?
3.
That's right, negative divided negative, just like multiplication, it turns into a positive. And 15 by 3 by 5, which is 3. And that's all, okay? Took 1, 2, 3, 4, not much, 4 steps, even though it was very, I don't know, mainly confusing or has a lot of things. Right? It actually is not. So simplify each side, move the x's to one side in the numbers. Number 3 is basically combine and isolate, combine like terms. Combine these like terms like we did here. And isolate the x. Meaning, get the x by itself. You may have to divide or multiply, subtract, whatever. Use one of the properties of first degree equations. These are the properties, either multiplication, subtraction, or division. Okay, no matter how long the equation might look, just try to work on each side. Simplify that side. So this whole side here became this. This whole side became this. Once you get to this point, then move your x's to one side and numbers to the other. After that, you will have the x by itself. That's the solution. You can always plug it in this entire thing, and I can use the order of operations like this and check. Okay, that's pretty much as complex or as long as you can get. Remember the main steps. Main steps are here, work on each side, combine, and isolate the x. Of course, again, everything we learned before, everything we learned in a class is used in the next class. So basically we combined a bunch of things here. Combined signs, the rules of the signs, the rules of the properties of real numbers, distributive property. Also combined PEMDAS here, just to check. Pretty much everything we learn, again, is used somewhere. So again, you can always go back to the previous lectures whenever you have any doubts, you forgot anything, rewatch it, especially with the one with the signs, because that's very important. Let's see here. That pretty much covers it all. This is just an introduction to these equations. We can have more on them in the next, at least the next couple of classes. And we're going to be pretty much talking about equations for the rest of the course. So it's very important to understand this stuff as long as the signs. Any questions, everybody?
No.
Anybody else? You guys okay? The rest of the class, any questions? All right, so yeah, in the next class, we're going to see how to basically solve equations with fractions. So far, there's no fractions, but we're going to see how to solve equations, but with maybe one fraction, maybe two, maybe three, or even more, a bunch of fractions in an equation. So that's a whole separate topic. So we're going to talk about it in detail next class. For now, let me give you some practice problems to do on your own, just like this. Just a few problems.